Hey guys, I'm Brian.
I'm Karol.
I'm Nikola.
And this is R3CAP, real-time 3D motion capture. Today we're going to be showing the localization of an SDR using R3CAP. So, if you look over here, the software-defined radio, or SDR, is a transmitter transmitting at 915 megahertz. Has an orange cup on top of it. And the black plank is R3CAP, our device that we made. So each of the green PCBs on either end is an RF front end. It takes the signal it's getting wirelessly from the SDR and down converts it to about 5 megahertz to the point that the signal can be sampled by the FPGA. The FPGA does some digital signal processing and then sends data over through this USB cable to the host computer, which does a bit more processing to localize the SDR. So what we're seeing here is the orange ball, much like the orange cup, represents the SDR, and the black plank represents our plank of wood, and each of these white squares represents the squares on the plank so that we could sort of get our groundings and understand what this location means. So you can see that the ball is a bit behind the plank, and it's also above the plank, but not very far above it, about halfway of the distance of the plank itself above the plank. So that's actually what we're seeing here. So it is correctly localizing the SDR. So one of the things about R3CAP that's better than other methods of localization and motion capture is it works without line of sight. So if Karol now holds this shirt, which has a picture of Professor Fontaine on it, in front of the SDR, there's no line of sight between the SDR and between the RF front ends, and if we go look at the Unity program, we actually still see the SDR being correctly localized as expected. And that's R3CAP localizing an SDR.
Pretty cool, guys.